What you're about to hear isn't magic, and it isn't a one-size-fits-all solution. Everything in this video is purely educational, rooted in documented science, real history, and practical experimentation that has been studied and recorded for over 2 centuries. This is not electrical advice, this is not construction advice, and this is absolutely not a replacement for your home's electrical system or any licensed infrastructure. Before you try anything you see here, check your local codes, use appropriate safety gear. And if you're planning anything beyond a small backyard experiment, please consult a licensed electrician or engineer. Results vary enormously depending on your soil type, moisture content, mineral composition, and a dozen other factors. What works in the wet clay soil of the Pacific Northwest may barely move a needle in the dry desert ground of Arizona. This channel, Fix Survival Secrets, exists to bring you practical, forgotten, and underexplored knowledge, so you can make smarter decisions about self-reliance. We don't promise miracles here. We show you what's been tried, what the science says, and we let you decide what's worth exploring. Now, beneath your feet, right now, there is electricity. Not from a power line, not from a solar panel, not from anything man-made. The ground itself, the soil you walk on, plant in, and largely ignore, carries a measurable electrical charge. And for a brief window in history, a small group of engineers, farmers, and experimenters figured out how to pull that charge out and use it. They drove 2 different metal rods into the earth. They connected a wire, and they watched a needle move. No fuel, no battery, no generator, just dirt, metal, and chemistry older than civilization itself. So why don't we talk about this? Why isn't this in every self-reliance guide, every off-grid manual, every prepper handbook in America? And more importantly, what actually happens at the molecular level when 2 dissimilar metals make contact with soil? That is exactly what we are going to break down today. The year is 1841. A man named Alexander Bain, a Scottish clockmaker with a restless, brilliant mind, is standing in a field near Edinburgh. He drives 2 metal rods into the ground, 1 iron, 1 zinc. He connects them with a wire, routes that wire to a simple clock mechanism, and steps back. And the clock runs. No winding, no conventional battery, just the earth, 2 metals, and the invisible chemistry happening silently between them. Bain went on to patent the earth battery as a legitimate power source for telegraph lines, and for a brief moment in the mid-1800s, entire stretches of telegraph wire across the world were partially powered by the ground beneath them. Operators drove metal stakes into the soil at relay stations, connected them to the line, and used natural soil electricity to supplement their systems. This was not fringe science. This was not a backyard experiment. This was infrastructure. This was the 19th century's version of free, distributed, self-sustaining energy. And then, over time, as coal-powered generators became cheaper, more powerful, and more scalable, simpler methods like this one faded out of mainstream use. Not because they were disproven, not because they were dangerous, but because they were low output in a world that was rapidly learning to demand high output. That's how this knowledge quietly stepped out of the spotlight. And that is why most people walking around today have never once heard of it. But here's where it gets interesting. The underlying science never went anywhere. And in an era of rolling blackouts, off-grid living, and growing self-reliance, the principles behind the Earth battery are absolutely worth understanding, and understanding deeply. So let's talk about what is actually happening beneath the surface. When you drive 2 metals into the ground, let's say zinc and copper, which are among the most commonly used and historically documented combinations, you are creating what chemists call a galvanic cell. If you ever took a basic chemistry class, you might remember this. It is the exact same principle behind every AA battery sitting in your kitchen drawer. A galvanic cell needs 3 things: 2 different metals, called electrodes, and an electrolyte, a substance that allows ions to move between them. In a store-bought battery, that electrolyte is a manufactured chemical paste or liquid sealed inside a casing. In an earth battery, the electrolyte is the soil itself, and here is why that works. Soil is not just dirt. It is a complex, living mixture of minerals, organic material, water, and dissolved salts and acids. That moisture, combined with those dissolved compounds, makes soil electrically conductive, not highly conductive, not like a copper wire, but conductive enough to allow ions to migrate between 2 buried metal electrodes sitting in the ground. When zinc and copper are both in contact with this conductive soil, a chemical reaction begins immediately. The zinc, which is the more chemically reactive of the 2 metals, begins to slowly oxidize. It releases electrons. Those electrons travel upward through the wire connecting your 2 rods, pass through whatever device or measuring equipment you have attached, and return back into the soil through the copper rod. That movement of electrons, that flow, is electrical current. It is slow, it is low voltage, typically somewhere between half a volt and 1.5 volts for a basic single-pair setup. But it is real, it is measurable, it is documentable, and in certain limited applications, it is genuinely usable. And this is where most people stop looking because they see the words low voltage and they immediately dismiss the whole concept. But that is exactly the wrong reaction. Think about what powers your TV remote. A small battery. Think about what keeps your wall clock ticking. Another small battery. Think about the sensors, the monitors, the indicators, and the small electronic circuits scattered throughout a modern American home or workshop. Many of them run on very modest, very low power requirements. A properly built multi-cell earth battery array, in the right soil conditions, can power small, low-draw devices. Researchers and hobbyists have used setups like this to run LED indicators, charge capacitors, power basic monitoring sensors, and, historically, keep telegraph equipment alive and transmitting. Is it going to run your refrigerator? No. Is it going to replace your solar panel array? Absolutely not. But as a supplemental power source, an educational tool, or an emergency low-draw solution for the prepared homeowner, it deserves far more attention than it currently gets. And here's a piece of history that almost nobody talks about. During the Civil War era, as telegraph lines were being stretched across this continent at a remarkable pace, earth batteries were actually field tested as backup power solutions when conventional battery stocks ran low. Operators in the field knew that in a pinch, they could use the ground beneath them to keep a signal moving down the line. That knowledge was practical. That knowledge was survival level useful, and it was common enough that telegraph operation manuals of that period included written instructions for constructing earth batteries right there in the field. We have simply forgotten. Before we get into the practical side of this, the actual step-by-step, I want to pause and ask you something directly. Have you ever experimented with anything like this? Off-grid power setups, alternative energy experiments, soil conductivity, anything along these lines? Drop your state in the comments below right now. I am genuinely curious, because soil type matters enormously with this concept. And I would love to hear from people across different regions about what conditions they are actually working with. And if you are new to Fix Survival Secrets, this channel exists for people who want to understand the practical, the forgotten, and the underexplored side of self-reliance. If that sounds like your kind of content, hit subscribe. New videos go up regularly, and you will not want to miss what is coming next. Now let's build. Here's how to construct a basic earth battery experiment right at home. This is for educational and exploratory purposes only. Start small. Measure carefully. Learn from what you observe. Here's what you will need. 2 metal rods or plates made of different metals. Zinc and copper are the classic and most widely recommended combination. You can find zinc-plated rods or pure zinc strips at most hardware stores. Copper grounding rods or sections of copper pipe at any home improvement store across the country. You will also need insulated wire, a basic multimeter, which you can pick up for under $20, and a patch of accessible soil to work with. Step 1. Choose your location carefully. Moist soil performs dramatically better than dry soil. If you are in a dry climate, a garden bed that receives regular watering is a far better starting point than open yard soil. The more mineral-rich your soil, the better your results will be. Clay-heavy soils and soils near decomposing organic matter tend to be noticeably more conductive. Step 2. Drive your zinc rod into the ground. Aim for at least 12 inches of depth. Soil conductivity generally increases with depth because moisture levels tend to be far more stable below the surface layer. Step 3. Drive your copper rod into the ground, at least 2 to 3 feet away from the zinc rod. Distance matters here. You want the chemical reaction to occur through the body of the soil itself, not just across the surface. Step 4. Connect a wire from your zinc rod to one lead of your multimeter and a wire from your copper rod to the other lead. Step 5. Take your reading. In favorable conditions, moist, mineral-rich soil, you may see a voltage reading anywhere from 0.3 volts to well over 1 volt with just a single pair of rods. If you see very little or nothing at all, try watering the area around your rods thoroughly and then remeasure. You can also try adding a small amount of dissolved salt to the soil near the rods. This increases ion concentration and can improve conductivity significantly. Step 6. If you want to scale up, connect multiple rod pairs in series. The zinc rod of your first pair connected to the copper rod of your second pair, and so on from there. Each additional pair adds voltage to the system, working the same way as connecting batteries end-to-end in a flashlight. Some hobbyists have documented small earth battery arrays producing enough consistent output to power an LED light or basic electronic sensor for extended periods of time. Document your results carefully. Measure in the morning. Measure after rainfall. Measure across different seasons. The data you gather from your own specific soil is more valuable than any general guide, because your land is unique to you. Now, let's be fully honest about the limitations, and there are real ones worth understanding before you invest time or money. First, output is low. Even a well-designed and carefully optimized earth battery array produces only a fraction of what any conventional power source delivers. For anything beyond very low draw applications, this is a supplemental or experimental tool, not a primary power strategy. Second, the zinc electrode degrades over time. Because zinc is the reactive metal in the pairing, it slowly oxidizes and wears down with use. This means an earth battery is not indefinitely self-sustaining. The zinc will eventually need to be replaced or refreshed. Third, soil variability is enormous across this country. What produces strong results in one region may produce almost nothing in another. Sandy, dry, low mineral soil has poor natural conductivity. If you live in an arid region, your baseline conditions are simply less favorable, although smart moisture management can help close that gap. Fourth, expect seasonal variation. Soil conductivity shifts with temperature and moisture content across the year. Your earth battery setup may produce noticeably different output in January compared to July, or during a wet spring compared to a dry summer. And finally, if you are ever thinking about moving beyond small-scale experimentation, always check your local regulations first. Burying metal in the ground, particularly near utility lines or property boundaries, can carry legal and safety implications, depending on where you live. Here is what we know. 2 different metals buried in moist soil will produce a measurable electrical reaction. That reaction follows the same galvanic chemistry that powers the batteries in your pocket and your remote and your smoke detector. It was documented in the 1840s. It was used in real telegraph infrastructure. It was studied by researchers across 2 full centuries. And it has largely been overlooked in the modern era as grid-scale power became the dominant force in American life. That does not mean it is useless. It means it has been waiting, sitting quietly in old manuals and forgotten field notes, for the right moment to be rediscovered by the right people. If you take one single thing away from today's video, let it be this. The earth beneath you is not electrically neutral. Your soil is a chemistry lab, and with the right materials, the right conditions, and realistic expectations, you can interact with that chemistry in ways that most people walking over that same ground will never once consider. Before you go, a final word. Everything discussed in this video is for educational and informational purposes only. This is not electrical advice, this is not construction advice, and it is not a substitute for professional guidance. Local codes vary, safety conditions vary. Always research your specific situation thoroughly and consult licensed professionals wherever appropriate. Fix Survival Secrets does not guarantee any specific result from the concepts or experiments discussed here. If this kind of deep, practical, forgotten knowledge is what you have been looking for, you are in exactly the right place. Subscribe to Fix Survival Secrets. Leave your state in the comments and tell us whether you have ever tried anything like this. And share this video with someone who thinks they have already heard everything worth knowing about self-reliance. Because next time, we are going somewhere that even most off-grid communities have never looked. Stay curious, stay prepared, and we will see you in the next one.